we are going to see how does move how does object move, motion of object. We will observe types of motion of moving object. A lot of things will be covered in this lecture. Name of this lecture is motion, and it's a description. This is a part 2. I will be explaining part 1, but right now we have a part 2 of this lecture. Name of this lecture is written over here, and the standard is ninth. As you can see, my name is written over here, and it's me. Mm, in this slide you saw name of this lecture, standard, my name. This is part 2, it's me. Now we are going to start because I am not here uh, to waste your time. Okay, I am not here for this. So let's start from this slide, which is about what we have learned. This is about, it is telling you that we have learned in part 1, and in part 1 we learned what motion, distance, displacement, about uniform motion, non-uniform motion. If you are those who were not in the lecture of part 2, then okay, uh, don't feel okay, this is not problem. I would say this is not problem because I didn't explain that part 1. So here we have this, then this fourth today's session. In this lecture we will be explaining this, but can we explain this? Of course yes. If this is a part 1, then we can explain it. Motion. Look, it is saying a object which is in motion. A object will be moving, means will be covering distance, as well as a object will be taking time to move from one place to another place. When a object is moved, that object changes place, its position. This is what is the meaning of object which will be in motion, which can come into motion. A body is said to be in a rest when its position changes constantly with respect to a stationary object. This is in book language. From our language we can understand a object will move. When a object will move, then that object will cover distance. And when a object moves, then it moves with time. It keeps covering time with the covering distance. Clear? So motion, which means a object will move, then that object will cover distance as well as time. At the same time, it will be changing its self position. Distance, it is a total path. We don't ignore anything when we are measuring something. When we are measuring something, then we will not be ignoring anything. But in the discussion of a displacement, you will ignore something. This is the difference between distance and a displacement. Here, distance explains that I will take all those things, all those lengths from one point to the second point is a 5 meter, then from second point to the third point is again 6 centimeter. Then total of this is the total how much? 11. That this 11 is the distance. Total 5, 6, 11. 11 centimeter is the distance. This was about the distance. Path length. It is a scalar. It is considered as a scalar. Distance is considered as a scalar. Now, here we have a scalar word. What is the meaning of this word? Meaning of this word is a scalar is a quantity. Distance is a quantity. A scalar is a quantity. It has only what magnitude. What does magnitude mean? It will have numbers with units. It will explain numbers with units. A scalar explains numbers with units. It does not provide a direction. Who will provide? Vector will provide a direction. So remember, it is a distance. It is considered as a scalar because the distance does not provide direction. That's why it will only provide magnitude. Okay. Displacement is a shortest path. We don't go this side. No. For displacement, we will start from one point till we will be going into straight direction till the second point. This shortest part will be displacement. And it is said that displacement will be considered as a vector. Now when it will come to vector, you know displacement has direction. That's why people are saying displacement is a vector quantity. It is done. Next we have uniform. Motion. There is object which is moving. If a speed is fixed, a speed of a moving object is fixed, then that type of motion is a uniform motion. This is what is the meaning of uniform motion. Okay. After 1 hour, a moving object is covering how much distance? Let's assume 35 kilometer. Again, it covers the same distance within the same time. This type of motion of object will be considered as a uniform motion. This is what uniform motion. When a object will be covering some distance within some distance, and it is the same again, this type of motion is a uniform motion. A body has a uniform motion if it travels equal distance in equal time intervals of a time. Non-uniform motion, a body has a non-uniform motion. Simple non-uniform, which means a speed will be increasing or decreasing. This is what is the meaning of non-uniform. Non-uniform is not fixed. It is not constant. That's it. As you know, if you start traveling from your home, then you are going to your college with your bike, then what will happen? Sometimes you will decrease the speed of your vehicle. Sometimes you will increase according to requirement, according to need. And this is what is our requirement. Anytime we cannot fix a speed of our vehicle. And no. So non-uniform is what? Changing of a speed of object is a non-uniform motion. Now here we saw a object will be covering some distance, some distance in equal interval of time, then it is a non-uniform. because of it distance is what within a 1 hour distance a object covered a object traveled 15 kilometer, but again within a 1 hour it is not same, it is not same. In the second case, the same object is traveling how much a distance, 70 kilometer within a how much, 45 minutes. It is changes. This type of motion of object will be non-uniform motion, will be non-uniform motion, remember always. Now next we have a speed. This is formula of calculating a speed. Formula of a speed is a distance upon time. For calculating distance is a speed into time. Unit of a speed would be meter per second. It will tell you what is which one vehicle is moving more fast, which one vehicle is moving, which one object is moving slow. So a speed will tell you with this much speed your vehicle is moving. Who will tell you? A speedometer. To find a speed you will have to observe a speedometer device which is available in your vehicle. A speedometer provides a speed of a vehicle, of a moving object. Okay, it will tell you in meter per second. Uniform speed. What is uniform speed? Equal distance in equal intervals of time. Meaning is the same as we saw about uniform motion. Same here. After 5 minutes, a speed is the same, and a speed is what? 5 meter per second. 5 meter per second, and again it is the same. This is what uniform speed. A speed would be same after 1 hour, after 2 minutes. Okay, equal distance and equal intervals of a time. Now what is the average speed? Just a total distance upon total time will give you average speed. Sometimes you will stop, sometimes you will decrease the speed of your vehicle. All this distance will be taken for calculating average speed. By calculating average speed you will have what? With this much speed you were riding vehicle. From this average speed you will be able to calculate. In uniform speed we are observing that yes, distance is same, speed is the same, but average speed will tell you that sometimes you decreased speed, sometimes you will be increasing speed. But here what are we observing? We are observing changes of a speed, that's why we will take total distance. Sometimes you covered some distance within some time, then again you started moving, you started riding, then what was now distance that you covered within a particular time. You will take all this distance, then upon all time that you took. Now next is velocity. velocity of a body is the distance traveled by it. It is like a speed, but a speed does not have a direction, but velocity has a direction. This is what is the difference between a speed and velocity. Okay. Velocity will also tell you a speed, but it will provide a direction. This is what is the difference between it. Per unit time is a given direction. Per unit time. Unit of a velocity will be same as we saw for a speed. Unit of velocity would be meter per second. Here we have velocity. This is a formula. Here we saw definition of a velocity. Here we have a formula of calculating velocity is that displacement upon time taken, because displacement is a it provides a direction. That's a time taken. How much time was taken, you will write over here. Displacement can be represented as s, and time taken will be represented as a t, and velocity will be represented as v. Unit is what, meter per second. I have told you already. Now next is the uniform velocity. It means a speed will be uniform. Sometimes it will not decrease, sometimes it will not increase. A speed will be fixed, and here a speed will be fixed, and you can take a direction. You can take a direction. You can take turns, but still a speed will be same. There will not be any changes with a speed. A body has a uniform velocity if it travels in a specified direction in a straight line and moves over equal distance in equal intervals of time, no matter how small this time travels may be. It is telling you it is a possible when there is a uniform velocity. If you are going into straight direction, if you are moving in a circle shape, then it will be possible to see as a nature view of a uniform velocity with the vehicles. If you are adding vehicles, if you are adding a bike, then your speed sometimes is your speed is what's fixed. Your speed is fixed. Now there are 3 turns, and you will have to take one turn, which is a compulsory. A road goes after taking one turn. Now what will you do? You will decrease a speed of your vehicle. This is what will happen. Here you will not increase the speed of your vehicle to take turn. Turn. Remember. So when you will decrease a speed of your vehicle, then this will not be definition for uniform velocity, because here we are considering velocity as a uniform. That's why I am saying when you will take a turn, then you will decrease the speed. It will be impossible to take a turn with the same speed as much you will be coming with the same speed. Now next we have a speed and velocity are not always equal in magnitude. A speed and velocity are not always equal in magnitude. Okay. Acceleration of a body is defined as the rate of change of its velocity with the time. Yes. Acceleration is just increasing the speed or decreasing the speed of object with the time. This time a speed of vehicle, a speed of object was this much. Sometimes it was less, sometimes it was more. If this is happening with object, it means it is a acceleration. It is a acceleration. We can directly say with one word that yes, it is acceleration. Now next we have a is equal to v minus t, v minus u upon t. It is a formula of calculating acceleration. It is a formula of calculating acceleration. Here a is acceleration. A was represented as acceleration. V will be final velocity and u will be minus velocity. From this you will get total velocity upon time. The SI unit of acceleration is meters per second. Okay, the SI unit of acceleration is meter per second a square. Okay, a square here, not only meter per second, a square. This was about acceleration. What is the formula of acceleration? Just v minus u upon t, upon t. We are taking what v minus u because of sometimes object will be decreasing in speed. That's why initially what was a speed of a moving object, and at the final position what is a speed of a object. This is what will happen. That's why we will take v minus u. V minus u will define a initial velocity of the object and final velocity of the object. Now we came to the main discussion that we wanted in this lecture. In this discussion, in this lecture we will understand about uniform acceleration, non-uniform acceleration, about positive, negative and zero acceleration. It will be interesting for you. Area under the speed time graph gives the distance traveled by the body. The three equations of motion are v is equal to u plus at, s is equal to ut plus half at square. These equations are formula, you can say. If you wanted to know what is the final velocity, then this is a formula. If you wanted to calculate a displacement from acceleration formula, then you can apply this formula. Okay, this formula. So here derivation of the equations of motion circular, all about this will be covered. Now here we are starting from this we are starting from this discussion. Uniform acceleration, it is telling you that velocity is fixed because we took a uniform word, that's why. So a speed would be fixed. Okay, velocity increases by equal amounts in equal times of equal intervals of time. The velocity time graph of the body having uniformly accelerated motion is a straight line. This it is in book language. From your language you can understand about the uniform acceleration. As I told you, a speed velocity will be fixed. That's it. This straight line tells what a speed is a constant. A object is moving with a constant speed. This is what is the meaning. Constant speed. You would say here we are understanding uniform motion, uniform speed. Yes, it will come. Now we have this. From this figure you will observe what about uniform motion. This figure is for you. I have explained this figure. Next I am moving. Here, as you can see here, what is happening? In the first here you are observing uniformly accelerated motion. uniformly accelerated motion. Here, a speed of this moving object is what fixed. Is what fixed, and this moving object is providing direction. That's why in the formula of acceleration we take a velocity. Now next we have non-uniform acceleration. Velocity increased by unequal amounts in equal intervals of time. The velocity time graph of a body having non-information acceleration is a curved line. Non-information, which means a curved line. Uniform, which means a straight line. It is telling you a speed of a object. Here is this object is in a rate. It started moving. So here it is moving slowly. Then immediately a speed of this moving object here it increased. A speed of this moving object here immediately suddenly increased like this. So are you seeing here gradually this is moving. This it is not telling you about a fixed speed. It is a non-fixed speed. It's a what unconstant speed, because here a speed of object changed. Here a speed of this moving object is high, more. It is a meaning of a non-uniform acceleration. Non-uniform acceleration. Okay, I am moving forward. Here as you can see, initially a speed of this vehicle is more, but as it goes as it moves, then a speed of it increase, isn't it? Now next is retardation, de-acceleration or negative acceleration. If the velocity of a body increase, here you can see, if the velocity first initial speed of a moving object will be less, then it will be increasing. A speed of a moving object will be increasing gradually, then this will be acceleration. I think the acceleration is a positive. Acceleration would be positive because it started moving slowly, then a speed of a moving object became high. From slow to fast is a positive. This if object a speed of object is less, then it is gradually it became more. It means acceleration is a positive. And if the velocity of the body decrease, then it means initially a speed of moving object is more, but gradually, slowly, the speed of moving object became slow. Initially it was more, but at the final it was slow. So here acceleration is a negative. Acceleration is negative because of from high to slow, because it is what high to slow, from high to slow. The acceleration is negative. Okay, till here it is done. Retardation, it is new, but after understanding this will be your friend. Retardation is measured in the same way as acceleration. Retardation is actually acceleration with the negative sign. Yes, it is. We were saying that if acceleration is negative, then this negative acceleration can be called as a retardation. Or deceleration. You can call negative acceleration as a deceleration or as a retardation. It depends on you. Clear? So if here from here object is moving, let's assume from here object is going in this direction. From here to till here, it started from this. Then it is what? Positive, positive acceleration. But what if object is over here? It is coming like this. It means here initially a speed of this would be, velocity of this would be more, but here it will become less. So from here to till here, it is this acceleration is a negative. What about the zero acceleration? Zero acceleration, which means object will not move, object will not move at all. So till here it is done. Average velocity, average velocity, average velocity is equal to initial velocity. Okay, not average acceleration, it is the average velocity, initial velocity plus final velocity upon 2. V is equal to u plus v upon 2, initial plus final velocity upon 2. Then we will divide, after adding u plus v, we will divide by 2, this by 2. Then you will get average velocity. This is the formula for calculating average velocity. You can use this when you are moving to numericals. Then you will have to use this formula according to requirement. When a bar on the V denotes the average velocity, u is the initial velocity and v would be final velocity. It was represented on u and v was represented on bar graph. Here you can see what is happening here. This horizontal is about the time and this vertical is about the distance. It is a distance in meters and this is a time in seconds. From this you will get clarity. From this you will get clarity. Let's see what is happening. This is a straight line. It is already uniform motion. This is a straight line. It is already uniform motion. Now, if a object started moving from here to till here, then it is this acceleration is a positive. Now, look at this blue line. Look at this blue line. From here to till here, this speed is fixed. From here to till here, the speed is fixed. Again, from here to till here, from here to till here, object is not moving. From here to till here, object will not be moving. Here acceleration is 0. Acceleration, this is a straight line, but it is not a vertical and not a horizontal. It is coming between, but line is a horizontally, and horizontally line will explain a object which is not will not be moving at all, but time will be passing. So acceleration would be 0 when object will not be moving at all, but time will be passing. From here, a object started moving from here to till here. From here, acceleration is a positive because it is going from downward to upward. That's why this acceleration is a positive. But here what is happening? Distance is the same 40, but time is passing. It means this object is not covering distance. Okay, here. Now it is going downward from upward to downward, then acceleration would be negative. From upward to downward is considered as a negative acceleration. Negative acceleration. Negative acceleration. Now here let's see. It was look at this red line. This object was here, which is in rest which was in rest, it started slowly and it started slowly moving. Then here immediately it in a speed of this object increased, and you can see here, and here it is decreasing. Speed is decreasing here. Of course here object will stop, object will stop. From here to till here object is stopped here because it is horizontally. That's all. That's why time. The green line shows a fast steady speed. Gradually it will be increasing. It will be increasing. The speed of this will be increasing, but steady with the equal time. Time will be equal and distance will be equal. The blue line shows a journey with a slope and a return to the starting position. The red line shows a journey starting 2 seconds later than the other two, with an initial acceleration, then a deceleration, then a stop. It is in book language. In our language, we have understood about this graph. Now we are able to move towards. Next we have question. What will be the shape? What will be the shape of a velocity time graph for a uniform accelerated body? When it will come to uniform, then of course shape. What will be the shape? Not shape. Slope. It will look like this. And shape would be like this. So let's see what is the answer. Yes, answer is correct. That we answer. It will be like this because it is for uniform accelerated body. Now next, answer is straight line. Next is a stone is dropped from a certain height. What kind of acceleration it will have? From a certain. So of course, again straight. But what kind of acceleration? Question is what kind of acceleration it will have. So of course a stone is being dropped from a certain height, from upward to downward. Acceleration would be negative. Suggest an example for a body having zero velocity but non-zero acceleration. So object will be in a rest. Let's see answer. Positive, negative. So here a speed was increasing. A stone is dropped from a certain height. What kind of acceleration it will have? Positive. Okay, positive. Next, yes, when a ball throw up reaches its topmost point. This is for you. Next, we have graphical representation of motion. Graphical, we have seen, but again, we can see. This is a distance and this is a time. Here, it started, then this is a steady speed. Gradually, a speed is increasing, but here a speed is a constant. Now, this is a decreasing. From high to low. This will be from here to till here, acceleration would be negative. From here to till here, acceleration would be 0. From here to till here, acceleration would be positive. So it is a what fast steady speed. Gradually a speed will be increasing. Now this is what getting faster. Gradually it is a increasing rapidly a speed. It is increasing rapidly a speed. Now next we have this question. A speed time graphs when the speed remains constant, then slope will look like this. This is not slope. When a speed is so constant, then line will be like this horizontally. Okay, horizontally. Let's read this. If the speed time graph of the body is in a straight line parallel to the time axis, then the speed of the body is a constant. This is what I was saying. In a speed time graph, the area enclosed by the speed time curve and the time axis gives us the distance traveled by the body. So you have understood what is it trying to tell you? Is it trying to tell you? Now we are able to move towards. In this slide, this was about how this was about a speed which remains constant. Then what type of line will be formed, will be created on graph? So of course this type of line, it will be parallel to time axis line. Now next we have this. A speed time graph when a speed changes at a uniform rate. Gradually it will be increasing. Slowly the object will be increasing a speed itself. Uniform rate. The speed time graph for a uniformly changing a speed or uniform acceleration will be a straight line. The slope of a speed time graph of a moving object gives its acceleration. A straight line sloping upwards shows what uniform positive acceleration upward. From downward to upward, it shows positive acceleration. Clear? This was about in this slide is about positive acceleration. Now we have this. We have two vehicles. Here, 50 meter per hour, and this is moving with the 70 meter per hour. 50 meter. Here you can see this vehicle is increasing a speed itself, isn't it? Here a speed of this moving object is 50 meter per hour, and here the speed of this velocity of this is how much? 70 meter per hour. Of course here it is more and here it is less. From here to till here it is more. That's why from less amount of speed till the till the more amount of speed will be positive acceleration. From less till the more. Here what is happening? From more till the less will be negative, as we know. But it doesn't matter if this is coming from upward, and initially upward a speed of a object is more, then gradually it is increasing, then that acceleration would be negative. But it does not happen anytime. Here what is happening? A speed of this is 50 meter per hour, but here it decreased. A speed decreased. The speed of this vehicle decreased. That's why this would be negative acceleration, and this can be called as deceleration or retardation. Now we are moving. Here we have this acceleration. We can find out the value of acceleration from the speed. from the from the speed time graph of a moving body to calculate the acceleration at a time corresponding to a point. I think it would be question. I'm ignoring this slide. Let's see what is it. A speed time graph when the initial speed of the body is not zero. Here, uh, in a speed time graph of a body, a straight line sloping downwards from here to till here, downwards, indicates Uniform retardation. Here it is initial velocity is not already it is telling you initial velocity of this object which is here is not a zero. If it is not zero, then of course it would be more. It would be a number except zero. It can be what 20, 50. Here it is more. It is coming downward. So here we would say a speed is decreasing. That's why this will be what this slope will be retardation. Uniform retardation. Now I am moving forward. How to find acceleration? By using formula we can find acceleration. Velocity time graph. The velocity time graph. So we have completed 20 slides. Velocity time graph. We are going to visualize velocity. The velocity time graph shows the motion of a particle for 1 minute. Calculate each of the following. In 1 minute, you will realize what a speed of a particle. Here, the acceleration in the first 10 seconds, be it the total distance traveled. Oh, we have numericals. Let's see. Here, what is happening? 10, 20, 30, 40, 45, 50, 45. The acceleration in the first 10 seconds from here to till here. Acceleration is what? Just I think 6 minus 0, 6 upon time. How much time was it? Is it taking 10 seconds? So 6 upon 10 will provide what? 0.2 meter per second a square. Here formula was used and time was given, as well as velocity is also given. Just you have to calculate what would be acceleration of this question. Based the total, we have to calculate the total distance traveled. So I think from here to till here it is how much? 30. I think it is how much? Not a 30. Not a 30. 30. For total distance you use this. Okay. The total displacement, then you here from here to till here you will use what? Three equations of motion. I am ignoring it, but it doesn't mean that it is not important. I am not comfortable with this numerical, that's why right now I am ignoring it. I have given hint is that you will have to apply formula of three equations of motion from here to till here. Okay, Next, we have distance as the area under the speed time graph. The distance traveled by the body in this case is equal to the area of the trapezium. Trapezium is a quadrilateral. Area of a trapezium is equal to sum of two parallel lines. Two parallel. So distance traveled is equal to this. Area of the rectangle. You will be going into too much details. Here you can see this is what here body is not moving. Here body is moving rapidly after coming here, and here a speed is a constant. Speed is uniform. Here what is happening from here to till here? Acceleration is a positive, but from here to till here, acceleration is a negative. Acceleration is a negative. If an object is coming from here to till here, and initial speed is not 0, then it is a retardation. Here same as you can see, from here to till here it is a positive acceleration. Positive acceleration. You have a question. There are some questions for you. A bus increase its speed from 60 km per hour to 120 km per hour in 5 minutes. Find the acceleration of the bus. So initially a speed of a bus was 60 and final 120. So 120 minus 60 will give you 60. 60 upon time is how much? Within how much time this speed increased? The speed was increased. So 5. 60 upon 5. So answer would be 12. 12 is the acceleration. 12 is the acceleration. 12 meter per second a square, which means after 1 minute, 12 12 meter 12 kilometer 12 kilometer was covered after 1 meter. This is what is the meaning of a 12 meter per second square. So this was answer. 12 is the answer. Second is a train is traveling at a speed of 90 km per hour. Brakes are applied so as to stop it in 5 seconds. Find the acceleration. Of course, we know acceleration would be negative. Acceleration would be negative. Here acceleration is a positive. So 90 and after 5 seconds. So you will apply what formula? Three equations of motions. This is for you. Here you can see initial speed of a train is how much? This much meter per second. Final speed. Okay, here it will give you how much? 12. I think it should be 12. Let's see. No, here acceleration is positive. Always remember, with the number you are getting positive sign, then you would say acceleration is positive. In a number, if you are getting negative sign, that means acceleration is a negative. Clear? So I think it is a done. No, it is not done. There are a lot of discussions that is not possible right now to cover all this. Clear? I am not going to cover all this in this lecture. In separate lectures uh, I will be covering all those important discussion that we left. So right now it is enough. I am going to leave this lecture.